Bismillahirrahmanirrahim. In Unit 7, we will discuss about intrinsic semiconductor. Intrinsic semiconductor is a pure semiconducting material without any significant dopants added. It exhibits electrical properties that depend solely on its inherent characteristics rather than external impurities. Intrinsic carrier, generally represented by Ni, is directly proportional to the exponent of minus Eg over 2kT. The intrinsic carrier concentration increases exponentially with temperature, which significantly affects its conductivity. In this equation, Eg is the band gap energy, K is the Boltzmann constant, and T is the ambient temperature, generally measured in Kelvin. At absolute zero, nearly all intrinsic semiconductors, behave as insulators. As temperature increases, some electrons gain enough thermal energy to jump from valence band to the conduction band. In other words, cross the energy band gap barrier and creating free electron and holes in semiconductor. The concentration of charge carriers, not only electron but also hole, increases with temperature. Table 1 compare the number of intrinsic carriers per cubic centimeter in germanium, silicon, and gallium arsenide. It is interesting to note that germanium has the highest number and gallium arsenide has the lowest intrinsic carrier density. In fact, germanium has more than twice the number of gallium arsenide. Table 2 clearly reveals that the free carrier in gallium arsenide have more than 5 times the mobility of carrier in silicon. Mobility is defined as the velocity per unit electric field, and it is a factor that results in response time during any semiconductor, or particularly gallium arsenide based electronic devices. That can be up to 5 times those of the same device made from silicon. Note also that free carriers in germanium has more than twice the mobility of electron in silicon, a factor that results in the continued use of germanium in high radio frequency is its mobility. It, intrinsic carrier, intrinsic semiconductor devices have some limited application in electronics, photovoltaic devices, and sensors. In electronics, intrinsic semiconductors are used in various electronic components such as diode and transistor. Their properties can be tailored through very precise doping to create P-type or N-type semiconductor. Photovoltaic diode used in solar cell, intrinsic semiconductor can convert light energy into electrical energy efficiently, especially PIN diode, where I is generally insulated. Yeah, intrinsic semiconductor, sandwiched between P-type and N-type diode. Sensors, they have very various application in sensors due to their high degree of sensitivity to the temperature and light. Thank you.